Hey people, get ready to crush everyday IELTS and CELPIP tests for all modules and make your dreams come true. I'm your motivator and I'll be guiding you through the test prep videos. So don't forget to like, share, and subscribe, or you'll be missing out on some serious preparation.
Section 1. You will hear a woman booking a place on a guided city tour. First, you have some time to look at questions 1 to 10. Now listen carefully and answer questions 1 to 10.
Good morning, Historic York Tours, you're through to bookings. How can I help you today?
Oh, hello. Yes, I'd like to book a place, a few places, actually, on one of your guided city tours, if that's all right.
Absolutely, I'd be happy to sort that out for you. Let me just take some details. Could I start with your surname, please?
Yes, of course. It's Whitmore. That's Whitmore.
Whitmore, lovely. And your first name?
It's Claire.
Claire Whitmore, brilliant. And could I take a contact number for you, just in case we need to reach you?
Yes, sure. It's 07954 316820.
Let me just read that back, 07954 316820. Is that right?
Yes, that's the one.
Perfect. Now, will you be coming along by yourself, or will there be others joining you?
No, there'll be 3 of us all together. It's me and 2 friends from university. We're spending a few days in York, so we thought a guided tour would be a lovely thing to do.
Oh, wonderful idea. 3 people, I'll put that down. And did you have a date in mind for the tour?
We were thinking the 14th of July, if you've got availability on that day.
The 14th of July, just let me check. Yes, you're in luck, we do have places available. Now, we run a few different options. There's our Riverside Walk, a food and market trail, and our Heritage Trail. Have you had a chance to look at those on the website?
We did have a look, yes. We all agreed we'd love to do the Heritage Trail. It sounded absolutely fascinating, especially with all the Roman history.
Excellent choice, it's a brilliant tour. Now, on the 14th we have 2 departure times for that one, 9:30 in the morning or 10:15. Do either of those suit?
I think 10:15 would suit us better, to be honest. We're not exactly early risers, the 3 of us.
Not to worry at all. 10:15 it is. So the meeting point for the Heritage Trail is just outside the town hall. It's right on the main square. You should be able to spot it easily enough.
Oh, the town hall on the main square, yes. I'm pretty sure we walked past it yesterday, actually. That shouldn't be a problem.
Brilliant. Now, I do need to ask, do any of you have any dietary requirements? We provide a light refreshment stop at a cafe about halfway through the tour.
Oh, that's a nice touch. One of my friends is gluten-free, so it would be worth flagging that up, yes.
Of course, gluten-free, noted. I'll pass that along to the guide. And then finally, how would you like to pay? We can take a credit card over the phone, or there's the option of a bank transfer if you'd prefer.
A credit card would be easiest for me, I think. I've got it here.
Perfect. I'll take those details from you now. So just to confirm everything before we process the payment, 3 places on the Heritage Trail, 14th of July, departing at 10:15 from the town hall, and one of your group is gluten-free. Does that all sound correct?
Yes, that's absolutely right. Brilliant, thank you so much for your help.
My pleasure entirely. You'll receive a confirmation by email once that's gone through. I do hope you all enjoy it. The Heritage Trail really is one of our best.
I'm sure we will. Thanks again. Bye.
Bye for now.
That is the end of section 1. You now have some time to check your answers to section 1. Section 2. You will hear a university open day presenter describing campus buildings. First, you have some time to look at questions 11 to 20. Now listen carefully and answer questions 11 to 20.
Good morning, and welcome to Greenfield University's Open Day. I'm Sandra Whitmore, and I'll be guiding you around our main campus buildings today. We have a packed program, so we'll move quite briskly. I'll highlight the key features of each building, and you're welcome to ask questions at the end of the tour. Let's begin with the Hartwell Library, which is central to everything we do here academically. The original building was constructed in 1978, and it's been expanded and modernized significantly since then, though the core structure dates from that period. I do need to flag that the library is currently undergoing a renovation project on its east wing. This has temporarily reduced study space in that area, but all collections and digital services remain unaffected, and the work is due to finish before Christmas. From the library, we move to the Newton Science Block. It's one of the tallest buildings on campus with 6 floors in total, each housing a separate scientific discipline, from life sciences at ground level up to physics and astronomy at the top. You might notice the modern structure attached to the northern side of the building. That's a recent extension, completed just last year, which added a dozen new research laboratories and significantly boosted capacity for postgraduate research work. The Student Union building sits at the center of campus social life. It houses a games room, society meeting spaces, a convenience shop, and our very popular student cafe. That cafe deserves a special mention. It stays open until 11 o'clock at night every day of the week, including weekends, which is something students really value, particularly around deadlines and exam periods. Next is the Greenfield Sports Center, which underwent a major refurbishment program completed 2 years ago. The total cost of that refurbishment came to £3.5 million, funded jointly by the university and a private sports charity. The investment really shows. The sports center now contains specialist equipment for strength, conditioning, and performance analysis that you'd typically only find at elite professional training facilities. This includes motion capture technology and environmental simulation chambers for advanced athletic training. The Caldwell Lecture Theatre Complex is where all large group teaching and public events are held. Across its 4 interconnected theatres, The complex can seat up to 800 people at once, and the main auditorium has quite exceptional acoustics. Our final building is the Margaret Thornton Student Services Hub. It was named in recognition of one of our most celebrated former students, who later became a highly respected figure in national education policy, a wonderful example of what a Greenfield graduate can achieve. Inside the hub, you'll find academic advice, financial support, mental health services, and disability assistance all in one place. During the week it's open from 8:30 until 6, and on Saturdays from 10 o'clock in the morning until 4 in the afternoon. That brings us to the end of our campus overview. Maps are available at the information desk near the entrance, and we'll now begin the walking tour. Do enjoy the rest of your open day.
That is the end of Section 2. You now have some time to check your answers to Section 2. Section 3. You will hear two students and a tutor discussing a laboratory experiment on water filtration. First, you have some time to look at questions 21 to 30. Now listen carefully and answer questions 21 to 30.
Dr. Evans, Sarah, and I have just completed our water filtration experiment and we'd like to go over our findings with you, if you have time.
Of course. Before we get into the data, could you remind me of the primary aim of the experiment? I want to make sure we evaluate the results against the right criteria.
Certainly. The main objective was to evaluate the effectiveness of different filtration materials. We weren't comparing water sources or testing commercial filter products, we specifically wanted to measure how various materials performed under identical controlled conditions.
Good. And can you walk me through the experimental setup?
We built a filtration column using 3 layers, gravel at the top to remove large suspended particles, fine sand in the middle for finer debris, and activated charcoal at the bottom. We then ran 5 liters of collected river water through the column and measured the output quality at each stage.
That sounds like a well-structured approach. Did you encounter any significant problems during the experiment?
Yes, actually. The sand layer caused us quite a bit of difficulty. After running the water through a couple of times, the sand became completely clogged and the flow rate dropped dramatically. It wasn't a cost issue and it didn't fail to remove bacteria, it was purely a blockage problem that developed with repeated use.
We also tested each layer's individual contribution to water quality. In terms of reducing turbidity, that is, the cloudiness of the water, the activated charcoal outperformed both the gravel and the fine sand quite substantially.
Interesting. What about the visual clarity of the final filtered output overall?
That was genuinely a pleasant surprise. The water coming out at the final stage was far clearer than either of us had anticipated. We'd both set rather conservative expectations beforehand, so the result was better than expected.
I'm pleased to hear that. Now, the process clearly wasn't without its complications. What would you say was the single most demanding part of the entire experiment?
Without any doubt, it was calibrating the turbidity meter. The readings were inconsistent at first and we had to recalibrate the instrument several times before we could trust the data we were getting. That was definitely the most challenging aspect throughout the whole project.
And how did things go in terms of your timeline? Did the work fit within the scheduled hours?
Not entirely. The initial data collection phase overran by nearly 2 hours. We'd seriously underestimated how long it would take to establish proper controls and ensure each individual test was fully isolated from the others.
That's a very common issue at this level. Now, I noticed your protocol didn't include any trials at varying water temperatures. Was that a deliberate decision?
We did consider it briefly. However, we felt that properly exploring how temperature influences filtration rate and efficiency would require a completely separate study. It's something that definitely needs more research before any reliable conclusions can be drawn.
I agree entirely. On the question of accuracy, I'd strongly recommend that you repeat the key trials using distilled water as your control baseline. That would eliminate any pre-existing variables present in the river water and give your conclusions considerably stronger scientific validity.
That's a really valuable suggestion. We'll incorporate that into the methodology section of our report straight away.
For the final written report itself, I'd also advise including a comparison with industrial filtration systems. It will contextualize your laboratory results within real-world applications and demonstrate a higher level of critical thinking to the assessors.
We hadn't considered that angle at all, but it makes a great deal of sense. We'll definitely add that into the discussion chapter.
Good. Overall, this is promising work. Tighten up the methodology write-up, act on those suggestions, and I think you'll produce a very solid final report.
That is the end of Section 3. You now have some time to check your answers to Section 3. Section 4. You will hear University Lecture on the history and future of space telescopes. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning, everyone. Today's lecture focuses on one of the most transformative technologies in modern astronomy, the space telescope. Unlike ground-based observatories, which are inevitably hindered by atmospheric distortion and light pollution, space telescopes offer an entirely unobstructed view of the cosmos. Over the past 4 decades, these remarkable instruments have fundamentally reshaped our understanding of the universe, and the next generation of observatories promises discoveries that we can scarcely imagine today. The story of modern space astronomy effectively begins with the Hubble Space Telescope, launched in April 1990 aboard the Space Shuttle Discovery. Very shortly after launch, however, scientists discovered a serious flaw in Hubble's primary mirror. It had been ground to an incorrect curvature by a margin of just over 2 micrometers, producing frustratingly blurred images. This was an embarrassing and costly setback for NASA. Fortunately, in December 1993, astronauts on the first Hubble servicing mission successfully installed corrective optics, which fully restored the telescope's imaging capability. From that point on, Hubble operated across optical and ultraviolet wavelengths with extraordinary precision, capturing iconic images of star-forming nebulae, colliding galaxies, and distant supernovae. Its observations were instrumental in the discovery of dark energy and in constraining the age of the universe to approximately 13.8 billion years. The James Webb Space Telescope, launched in December 2021, represents a dramatic leap beyond Hubble's capabilities. The 18 hexagonal segments of its primary mirror are each coated in a microscopically thin layer of gold, which is an exceptionally efficient reflector of infrared light. Indeed, Webb was designed specifically to detect infrared radiation, allowing it to peer through dense clouds of interstellar dust and observe light from the very earliest galaxies to form after the Big Bang. One of the most remarkable engineering achievements of the project is its sunshield, a 5-layered, diamond-shaped membrane roughly the size of a tennis court, which maintains the telescope's instruments at temperatures below -233 degrees Celsius. Webb operates at the second Lagrange point, approximately 1.5 million kilometers from Earth, well beyond the reach of any crewed servicing mission. What is particularly striking when we consider this field is the sheer longevity of these observatories. The Hubble Space Telescope, for example, has now been in continuous scientific operation for more than 35 years, far exceeding its original projected lifespan of 15 years. Turning to future missions, NASA's Nancy Grace Roman Space Telescope is currently targeted for launch later this decade. The Roman telescope is especially exciting because it will possess a field of view 100 times wider than Hubble's, enabling vast surveys of the sky in near-infrared wavelengths. This capacity will prove invaluable for investigating the nature of dark energy and for detecting thousands of exoplanets through gravitational microlensing. Looking further ahead, astronomers and engineers are developing concepts for observatories that would be assembled in orbit using advanced robotic technology, entirely eliminating the size constraints imposed by rocket payload fairings. One of the most ambitious proposals is LUVOIR, the Large UV Optical Infrared Surveyor, which envisions a segmented primary mirror approximately 15 meters in diameter. This would be nearly 3 times larger than Webb's mirror and would provide the angular resolution needed to directly image Earth-sized planets in the habitable zones of nearby stars. Spectroscopic analysis of such planets' atmospheres could, in principle, reveal the chemical signatures of biological processes, a prospect that places space telescopes at the very frontier of astrobiology. In summary, space telescopes have journeyed from their imperfect and uncertain beginnings to become the most powerful scientific instruments ever constructed by humanity. As engineering ambition continues to grow, the observatories of the coming decades may ultimately provide an answer to the most profound question in science, whether life exists beyond our own planet.
That is the end of Section 4. You now have some time to check your answers to Section 4. That is the end of the IELTS listening test. You now have some time to transfer your answers to the answer sheet.
Hey people, how was your test? Don't forget to like, share, and subscribe, or you'll be missing out on some serious fun. See you tomorrow!